Okay, this one is the SPM module lesson. So that day I call you to finish for the Untitled Chapter. Have you do it? So I want to see. Okay, so okay, Yong Chun Lei, can you see my screen? Can okay, so you see the PowerPoint, is it? The SPM module question discussion. Yeah, so because I cannot, suppose I record already, but not enough time to upload to YouTube, so that's why I need to live. Okay, so I just continue to my lesson. So you just follow lah. If you cannot, better you text me. Okay, maybe you text here I cannot see. You text me in Telegram, then I can see. Okay, so I just continue. Okay, this one is the first question. Okay, the answer already is here because I cannot slideshow. So I just explain for the pendulum. Okay, you choose the correct answer by the cross. Suppose it's a cross. So from here I put a tick. So you follow the question. If they say cross, then you follow using the cross. So one complete oscillation should be start from P, then go to Q, then go to R, and come back to the P. So this one we call one complete oscillation. Okay, then we go to the question number 2. This one they show about the stopwatch. For 20 complete oscillation, so from here 20 complete oscillation, you must see the clear for the smaller scale. Okay, 10 to 15. So from here 11, 12, 13, and 14 is it. So the smaller scale is a 5 division. So the first one should be 0.2. Second, there's smallest. Then should be the 45 overall lah. For 20 complete oscillation, there's a 45 second. Okay, then the slide 2, they're talking about you need to tick. So I can tell you normally the first question and the second question, they will ask the simple question like this. Call you to tick, call you to underline. So from here, the first one, they ask you physical quantity for the time. Then should be the scalar quantities. Okay, then the number 2 is the second question. Okay, until here got anything you cannot see or anything you want to ask? Okay, I see the attendance here first. Later I check. Okay, so I continue. Okay, this one is the displacement time graph oscillating the spring in the water. Okay, you can see the amplitude keep decreasing. So from here you need to underline. Okay, damping the situation is when the amplitude, okay, not wavelength, it's the amplitude decreases. So from here, damping, why they got damping? Okay, first one should be water resistant, not air, because this one is happen in the water. Then energy loss, you can say about the friction. Okay, number 2, period. Period is a one complete oscillation. So from here, one complete oscillation, there's a 0.4 second. Okay, what's the frequency? You find frequency, that means you take 1 over 0.4, there's a 2.5. Okay, what will happen to the period? Okay, when the heavier load is using. Heavier load means a mass increase. Mass increase means the inertia also increase. Inertia increase means the period of oscillation also increase. Okay, then number 3. Diagram that show about cross-sectional for the water ripple tank. Bright and also dark fringes. So the wave for the water, there's a transverse. Okay, you see this question. They call you to complete the light ray. They pass through one of the crests. So this one should be the crest. Can you see the line I draw? That one is a blue. Okay, blue light, they concentrate to one point. That one is a bright. Okay, when the truth, you find it, the light just goes straight. After that, you find it, there's a dark fringes. Okay, this one dark region means the light not focused. They are diverging. Okay, after you label the line for the blue light, then you need to label the distance for the consecutive crest. That means the wavelength. So I label the wavelength here already. Got 3, either one. Okay, then we go and see the next one. Okay. Okay, any question you want to ask? Okay, then we go and see the C. When the frequency of the water wave is increased, then what happened? Okay, frequency increase sure is a wavelength decreases. Okay, because frequency and lambda should be inversely proportional. Okay, the speed of the water wave should be unchanged. Okay, then we go and see this part. This part is another sound wave. That's a tuning fork. Okay, they'll call you to underline the bracket. So the sound wave is a longitudinal wave. Okay, name the region X. Region X is here. The closer, that one we call compression. Okay, need to mark about the lambda. So we're going to mark compression to the nearest compression. So that one is a lambda. Okay, C. Tuning fork for diagram 1, vibrate in the water. Remember, the sound wave travel faster in the solid compared to the gas. So now in the water means what, the situation become increasing. Okay, number 5 is a resonance. Okay, the pendulum X will go to oscillate for the frequency is 2 Hz. So from here we find it. Which one is the same length must be vibrate together and also with the maximum amplitude. So when you just oscillate the X, the rest continue to oscillate because the track should be the same. Okay, now they say the pendulum oscillate with the maximum amplitude. So amplitude should be maximum, must be the length should be same. So it should be the pendulum M lah. So now we're going to see the next one. Give the reason why you say the pendulum M will oscillate with the maximum amplitude. First one, you can say about the length same. Number 2, frequency same. Okay, this one is what phenomena, then should be the resonance. Okay, then we go to the next one. Relearn, I'm fine. So because of the technician problem, then I cannot go to slideshow. So you see my photo here, they close a little bit about the question and also the answer. So that means never mind. Later I will upload the full one for you all because I record already in the PowerPoint, in the video. So later I will share to your Telegram. So now you just listen, follow this 1 hour lesson because we need to follow the timetable. Okay, so I continue. So okay, so any question? Anybody Telegram me? Okay, Leonard. Okay, I will check my Telegram. No, if not, I'm going to take my phone first. Okay, so we just continue again. Okay, Song Ho Boon, they asked me which paper. Okay, the paper is from 5, the module I passed to you all. Okay, so I continue this one. Don't waste the time. Okay, let's see this one. This one is a pendulum X. Just now they will stop to oscillate after a few minutes. So you need to sketch. So I want you to sketch. Before you start to draw the wave pattern, you draw the curved line first. You draw the curved line up and down. So later that means you fix the amplitude. The amplitude will keep decreasing because of damping. Okay, then the time oscillation should be the same. So you don't make it become shorter. No. The length should be the same, just the amplitude decreases. Okay, number 6, they show about the jigsaw blade oscillate horizontally 50 gram. Okay, then they fix at the end of the hacksaw blade. Okay, one is 50 gram and another one is 200. So you find it. What's the differences? This one question sure to call you to compare because we got section A actually got 2 questions is a comparison. Okay, let's see the first one. The graph. Okay, this one complete oscillation just using 1 second. This one is using 2 seconds. So that means in the 3 seconds, this one can make how many complete oscillation? They can make 3. But this one just can make 1.5. So from here, this one is what we understand from the question. Now we go to get the meaning of the displacement. Okay, displacement means the shortest distance between the final position and the initial position in the specific direction. Because direction is the displacement got direction, so you need to mention the the location. So if you normally we take the displacement is a shortcut from the original straightforward go to the final. That one we call displacement. Okay, next one we see the comparison. Okay, again 6.1 bigger 6.2. Don't write in symbol. You need to write the full sentence. Okay, now we need to compare the load. Load is this one 50, this one 200. Sure, the mass of the load fixed on the jigsaw. So you help me to change. Is it got any problem? The jigsaw blade. Okay, this wait Okay, the load in the 6.2 is bigger than 6.1 because 6.2 is 200. Okay, now we go to another one. Compare the period of oscillation. Period of oscillation is a 6.2 longer, 6.1 shorter. Okay, number 3, compare the number oscillation. This one number oscillation is a less. Okay, 6.1 number oscillation is more in 3 seconds. So now, okay, number 4, relate the mass, the load, and also the period. Okay, again, don't just write directly proportional. You need to write the variable. Okay, mass of the load is directly proportional to the period of oscillation. Okay, they will catch you. Then you will lose your mark. This one all is a careless mistake. So from here, another related period of the oscillation to the number of the 3 seconds. So inversely proportional. Okay, if your period become longer, number of oscillation will decreases. Okay, then we go to the C. What happened to the amplitude of the oscillation jigsaw after oscillate some time? Sure will decreases because your energy loss. So we can say damping. Okay, this one is some almost the same for the SPM, the format. Okay, then we go to another one, the comparison. Okay, question 7 is also comparison. You see what's the difference. Okay, 6.1, 6.2, the basin, the size should be the same. Okay, but the droplets is a different. Okay, 6.2, you see the droplet is closer, is it? Closer means the frequency is high. Okay, then we see the diagram for the 6.2. Okay, this one is a circular shape formed by the water wave. Okay, can you see the 6.2, the wavelength become closer? Wavelength become short. This one wavelength is further. So we answer the first one. The wave joining all the point which have the same, okay, wave fronts almost same meaning like the wavelength. The phase must be the same, then they join one straight line. That one we call wave front. Okay, compare the depth. Both depth is the same. Okay, the volume in the basin in the 2 diagrams should be the same. Okay, number 2, compare again. They say the droplets, compare the number. Number 6.2 must more than 6.1. Okay, frequency 6.2 is higher than 6.1. Okay, now we do the comparison. Compare the frequency and dripping water. Okay, if the dripping water more, that means the frequency must be more, is it? So from here, the frequency 6.2 more than 6.1. Compare wavelength and also the spreading outward on the basin. Okay, wavelength and circular. When you see the circular become closer, then the wavelength become less. So from here we find it 6.1. The wavelength is longer than 6.2. Okay, how about the relationship? Okay, relationship. The frequency of the dripping water to the wavelength can relate. So when the frequency high, wavelength must be dropped because there's an inversely proportional. Okay, the next one, the depth. What happened to the wavelength of the circular wave if the depth decreases? Depth decreases, what you think about the speed? The speed must be dropped, is it? Speed drop, wavelength also drop. So there is a decreases. Give the reason. So the reason is must talking about speed. Okay, because of the speed cause the wavelength become short. Okay, then we go and see this part, number 8. Okay, this one, the phenomena is a refraction. Okay, I want to mention again. If this one question you just write refraction, is it correct or not? Actually, that's a correct. They no need to mention refraction of sound wave or refraction of the water wave. You just mention refraction of wave also correct. When you just write refraction, also correct. Okay, but specific a little bit lah, because we don't want to make some mistake to let them to minus our marks. So we just write the full. Okay, what happened to the speed in the shallow region? So the shallow region must be decreases. Okay, then draw. First one, draw the normal line. Remember, normal line must be 90 degrees with the edge. That means when they separate the two different regions. Okay, after that, the incident ray. Incident ray is go straight because there's a 90 degree with the wave pattern. Okay, until here you need to bend towards the normal. After you bend, you make sure the wave pattern and the red color line must be in 90 degrees. So that will give you 2 marks. Okay, then the question 9 also same, is a wave. Okay, we see the comparison for 2 diagrams. Okay, first one using the perspective. The thickness is a less. Another one, the perspective, the thickness is a high. Okay, so from here we compare the 2 diagrams. This one, the wavelength become longer. This one, wavelength become shorter. So we see the meaning for the frequency, number of complete oscillation in 1 second. Okay, now comparison. First one they want to compare is a depth. Okay, the depth for the X and Y. X is deeper, Y is shallow. So X more than Y. Compare the wavelength, also same. X longer than Y. Okay, relate wavelength and also depth. Depth increase, wavelength increase, directly proportional. Name the wave phenomena, refraction. Okay, almost the same. Every year also come out the thing almost the same. Okay, this one C is a some explanation. Okay, they ask about the water will follow the shape of the shore when they're approaching to the shore. Okay, this one's the one of question 3 marks. You need to answer at least got 3 points. Okay, I see got any problem or not. Okay, other cannot see without the link. YouTube can be put C with link. Okay, wait got any question or not? Okay, hi. Okay, I still continue. Jenny, Premium, YouTube. Okay. Any question? Okay, now I continue about this one. Okay, the depth of the water decreasing. First one, you're talking about water decreasing. Okay, because when the water, when they start to move from the sea, at the center should be depth region, deep region. Deep region means the wavelength should be longer. So when they're near to the shore, you find it, the wavelength should be shorter, smaller, because the speed slow down. Okay, so from here, first phenomenon you're talking about depth. Second phenomenon you're talking about the velocity. Third phenomenon you must talking refraction. So we see the first one, depth of water decrease, velocity decreasing. Yeah, memang is low. Okay, so I slow a bit lah. So from here, the third one must be talking about the phenomena. I mean by you're talking too fast and moving the PowerPoint too fast. Okay, so that means I need to slow down lah. Okay, so from here, the third one I mentioned again. So the third one is a refraction occur. So you're talking about depth. Number 2, you're talking about velocity. Then number 3, you're talking about refraction. Okay, then we go to question 10. Okay, question 10 they show about the pattern when the water wave they move from the A to B. So you see the A and B. A is a deep area, B is a shallower. So you find it when they put the glass plate, this part becomes swallow. Okay, so from here we need to talking about the meaning for the wavelength. So meaning of the wavelength is the distance between two successive crests, or you can say truth. Either crest, either truth. The key word is successive. Okay, the next one is the B. Compare the wavelength for the region A and region B. Okay, region A and region B. So from here we see lah, region A sure is a deeper lah. So you just say region A, the depth is greater than the region B. Okay, 2, you need to mention complete the sentence. So just complete sentence, 1 mark. So that means when the water wave, they travel from the deep then to the shallow, then the direction propagation is refracted towards normal. Okay, D. Why most the beach resort are built at the Bay Area? So the Bay Area is a calm area. So you must talking the wave. When they just go there, what happened? They will spread to wider area, is it? When they spread to wider area, the energy will lost, then also refracted towards the normal because of swallow part. So the energy of the wave that spread at the bay, you also can say the wave refracted towards the normal. So the question 11, that's about the sound wave. Okay, they give you the info. 0.8 is a A, 3.2 is a D, 4.5 is a X. So this one X, suppose we got 2X. You can divide by 2. Okay, first one you go to answer what means a coherent wave. Remember when they say coherent, you must say frequency same. Or you say the lambda, the wavelength is the same. And same phase different. What means of same phase different? Same phase means the amplitude is the same. Okay, but the different phase mean maybe crest, maybe trough is okay. Okay, then we do the calculation. We need to find out what is the lambda. So lambda equal AX over D. So the answer is 0.56 meter. Okay, then the next one is the louder sound is heard due to constructive interference of the sound wave. State how the constructive interference occur. So constructive interference occur is crest meet the crest, or you say the truth meet the truth. So that one we call constructive interference. Okay, so we continue to the next one. Okay, is it all the 5 science 3 students enter the link? Click the link and go in. 5 science 3, I see Kaijet, I see Achai. Okay, others. Fan Chang Yao, is it here? Okay, then we continue. Okay, question 12 also is a sound wave. This one is an experiment. Okay, you see the speaker, both diagram A. Okay, teacher, can I ask you what is the meaning of same phrase? Okay, same phrase, the meaning is that means you how many amplitude up, another one must be how many amplitude up. I don't care up or down lah. Important your phrase, you're using one amplitude, another one should be one amplitude. So we say same phrase. Okay, different phrase, different means you can crest, you also can be truth, but the amplitude sure must be the same. Okay, Habun. Okay, then we go to this one. Okay, compare the distance x. So distance x, we see the diagram, then we know lah, 6.1 more than 6.2. Okay, A with 6.1 is less than 6.2. So relationship A and x, there's a inversely proportional. Okay, then a physical quantity that need to be fixed to make sure the relationship A3 is correct. So we got constant variable because you lambda equal AX over D. So the lambda and D must be constant. But normally we didn't write lambda unless the question got mentioned. We need to write wavelength. D, you also need to give the full sentence. Okay, phenomena, this one is an interference of the sound wave. Okay, B, frequency of the audio signal generator is increased. What meaning of frequency again? Number of complete oscillation per second. Okay, number 2 is what happened to the distance between the two consecutive louder sound. Okay, what happened? So that means when the frequency increase, lambda decrease. Lambda decrease means the X also decreases. So give the reason because lambda and the F is inversely proportional. Okay, and the lambda and the X is directly proportional. Okay, question 13. That one is a light. Okay, interference of the light. They're using monochromatic. So remember what means of mono. Mono means one. Okay, they're using the red followed by the blue. Then you see the diagram. This one is a red. Okay, red, you see the fringes. They are wider. Okay, but you count the fringes here is a less compared to the blue. Blue, the fringes is a more. Okay, but closer. So from here, what means of monochromatic? Okay, we got question. Okay, the question here is, exam can we write symbol like frequency for F? Cannot. Okay, we learn we need to write in full sentence frequency unless the question got intro frequency comma F. Okay, then your answer can be answer F. Okay, if no, you need to write frequency full words. Okay, then from here, what means by monochromatic? Monochromatic is a light. They only have one frequency, or you say one wavelength, then one color. Okay, they just got one color. Okay, then we go through the question. Okay, you need to comparison again. They state the two observations about the distance between the consecutive fringes from the red and blue. Okay, first one, two observation, what you can see from here. Okay, what we can see, the first one is I know the red fringes less low, then the blue fringes is smaller, is it? Okay, number 2 is I see the red fringes further, then the blue fringes is closer. Okay, this one is what I can see. So you see the answer here. They say the distance between two consecutive fringes for the red one is more than the blue. Okay, is it correct? This one consecutive, first to second, the distance is further. First and second, the distance is closer. Okay, number 2, distance between two consecutive fringes for the same light is equal. So number 2, they're just talking personal. They never compare red and blue. They're just talking blue or red only. Okay, let's see. I compare red. First fringes, second fringes, third fringes. Is it the distance same? So the distance is the same. Blue also same. First, second, and third. So first and second, the fringes also same. Second and third, fringes also same distance. So from here, we can say the distance between two consecutive fringes for the same light is equal. Okay, compare the wavelength red and blue. So red is longer than the blue. Okay, relationship, the wavelength for the light, red and blue light, distance between consecutive, there's a X. So there's a directly proportional. Okay, phenomena we formed by the pattern, there's an interference of the light wave. Okay, so we go and see again, got any question chat room or not. Okay, so Telegram, any question? Okay, then we continue. Okay, now we go to next one. Okay, this one is again there's a sound wave. Okay, let the student arrange like this. So they ask you what's the sound wave. So sound wave is a longitudinal. So this all the kind question about the wave always like this lah. Okay, louder sound can be heard by the student at this one position. Why they want to arrange it like this? Because they want to get constructive interference. Okay, C calculation, they want to find the wavelength. So lambda equal AX over D. So we get the lambda is 0.6 meter. Okay, D, frequency and the sound wave is increased. What will happen to the distance between the adjacent row? There's an X. So frequency increase, lambda drop. Lambda drop means the X also drop. X drop means the closer. Okay, X will decreases. Okay, give the reason for your answer. So you must mention frequency. Don't write F only. Frequency increase, wavelength decreases. Okay, question 15 again. There's a loudspeaker also for the sound wave. Okay, what meaning for the two coherent source? Okay, Song Ho Boon, coherent again. So the two waves, the source must have the same frequency. Okay, this is the key word. Same, phrase, different. Phrase means the up and also the down. So your phrase must be same amplitude, but different. You can say crest, you can say about the truth. So if your crest is 2 amplitude, so your another truth must be 2 amplitude. Cannot one 2 amplitude, another one is a 3 amplitude. Then one cannot follow the rules of the interference. So you must have the same phrase, different. Okay, then this one is the light. This one is a sound again, still sound. Okay, compare again. So the first one, compare the A 6.3 longer than 6.2, X 6.2 is more than 6.3. Okay, then the distance PQ to the source. Okay, loudspeaker D. So the answer should be constant. Both is the same. Okay, now we go to write the relationship. Okay, distance A and X inversely proportional. Phenomena, interference of the sound wave. Okay, see, this question will always ask. Okay, so this one is, give the reason why the loud sound and the soft sound are formed by the two loudspeakers. So the first one is, louder sound is due to the constructive interference. The soft one is due to the destructive interference. Okay, then we go to the EM, okay, electromagnetic, the spectrum. Okay, first one they say microwave. Okay, remember radar system must using the microwave. So microwave is a type of the, you can say transverse, you can say electromagnetic wave. Okay, calculation, this one is a two-way system. Okay, remember the wave, when you just send, you detect, then the wave will come back. So this one is a refraction. So when the question they ask about distance, you need to divide by 2. So from here I get 60,000 meter. Okay, 17 is a spectrum. Okay, make sure you know how to memorize. The R is a gamma ray. Okay, so from here they say the reason why they choose micro, because there's a high frequency. Then after that you need to do the calculation. 100 megahertz. Mega is power of 6. So when you just convert standard form, they become 8 hertz. 1 times 10 power of 8 hertz. Okay, 25. Continue with the calculation. Now they say what is the wavelength? Lambda. They give you the speed. So V equal F lambda. So you get it, the lambda should be 3 meter. Okay, D is the drawing. They want you to draw the wave pattern for the visible light. Okay, remember we start with the radio. Radio, the wavelength must be longest. Radio micro, infrared, then visible light. So visible light, the wavelength must be longer than the ultraviolet. Amplitude should be the same. We do not reduce the amplitude. So you need to draw the wavelength become further a little bit. Okay, question 18. Okay, we check. Got the other, got question or not? Okay, personal. Okay, so we continue. Go and see the diagram. Okay, this one 18. CRO, for the boy to clap his hand in front of the concrete wall. Okay, another one also same, they go to clap but in front of the thick curtain. Okay, now we go and see the diagram. Okay, so I want to zoom for you to see. I cannot zoom lah, this one not. Okay, never mind, you go and see here only. So you focus. This one is the first clap, then this one is the echo. So you find it, the echo compared to diagram, the 6.2, the echo become less already. Okay, the reason is what? The curtain. Curtain is a soft material that will absorb the sound, is it? So from here we go to answer. Tick the correct answer. Sound is a longitudinal. Characteristic of the surface of the refractor. So concrete is a hard, curtain is a soft. Amplitude for the refraction of the sound. So amplitude sure 6.1 is more than 6.2. Okay, now we base on the characteristic of the surface of the refractor and also the amplitude of the refractor sound. Make the relationship. The harder the surface, the larger the amplitude of refracted of the sound wave. Okay, the amplitude of the refracted wave and the energy of the refracted sound wave. Amplitude and energy should be directly proportional. Okay, number 3, again the relationship. Characteristic of the surface of the refractor and the energy of refractor sound wave. So if the characteristic become harder, the surface become harder, the energy refracted should be high. Harder refracted surface, larger energy refracted. Okay, D is so about the dolphin, the sending out the ultrasonic sound to search the food. So what is the characteristic of the ultrasonic? The first one, there's a high frequency. They're not same like the normal sound we listen. Okay, normal sound we just listen is until 20 kilohertz only. So ultrasonic means over. So we want to using the this one because there's a high frequency. Number 2, give the reason because they're easily to refracted. When they just refracted, that means the dolphin can be detected. Okay, so this one is what I want to present for the wave. So sorry for the disturb because I cannot using the PowerPoint for the YouTube. So from here I will upload now. So for the student you cannot see some of the answer. So very sorry. Later I will upload there. I will send the link to you all. So just thank you for your watching lah. So from here, okay, I will take attendance. So for the student you still not yet write your name, faster you write your name first. Okay, I will take attendance. Okay, so from here we just complete lah. So thank